How are we doing? D. Dykstra here with another math video on integration and indefinite integrals. Alright, so we have a few more examples, so maybe you just watched the previous video on that where we went over some of the structure and some of the basic rules of integration. We're going to look at some different examples, and then I have a challenge problem for you. So take a look at this. Here's the power rule once again for integration or antiderivative. The integral of a to the some constant a times x to some nth power. If we want to integrate that, or we want to find the antiderivative of it, what we'll do is a will stay by itself, and x to the nth power, we will add 1 to the power of the exponent, and as well as we will divide everything by that nth power plus 1. So, and then we will tack on a plus c. So let's look at some applications of this and some example problems. Now what I did was I put it in different columns here for us so we can see that the progression. And what we've got here is the original integral, okay, or the original problem, and then how we can rewrite it, because it's always good maybe to rewrite these in some cases. Then we move into how we integrate it, and the application of the integration. And finally, what is the simplified answer? Okay, so let's go through each one of these and see what we can do. All right, so in part A, our original integral is the integral of 1 over x cubed dx. We can rewrite 1 over x cubed as x to the negative third power, right? We can always rewrite exponents with either positive or negative exponents. And once we do that, then we can start to integrate. So we have x to the negative 3 plus 1 divided by negative 3 plus 1. We can simplify that a little bit before we make our final answer, and that will be x to the negative 2 power over negative 2. Negative 3 plus 1 is negative 2. Same for the exponent. And then our final answer in this case would be negative 1 over 2x squared plus c. All right? So negative 1 over 2x squared. That negative 2 says, hey, take it to the denominator and multiply it by the 2. And we can move this negative just up to the top. That's fine. Okay, you're multiplying either the numerator or the denominator by negative 1. So it comes out the same. All right, let's look at problem B. The square root of x. How can we rewrite that in terms of an exponent with a power? So integral of x to the 1/2 power dx. We take x, we take the 1/2 plus 1 in the numerator and in the denominator, or the power I should say, and then in the denominator. And then we simplify. 1/2 plus 1 is 3/2. We get 3/2 in the denominator. And then we can simplify that. Remember when we multiply or we divide by a fraction, we flip and multiply by the reciprocal. So your final answer will be 2/3 x to the 3/2, and don't forget, plus c. Anytime we have an indefinite integral, we want to add plus c because there's a possible constant hanging out. All right, last one. Letter C. This one, we've got combination here. So it's x squared plus 3x cubed. It might be hard to see, but that is 3x cubed dx. And we can rewrite that as two separate integrals. The integral of x squared dx plus the integral of 3x cubed dx. So now we just treat each one individually. So x squared is 2 plus 1 in the numerator, 2 plus 1 in the denominator. And then we move along to 3x, and that is going to be 3 plus 1, because it was cubed, over 3 plus 1. And now, that means we have x cubed over 3 plus, now this is going to be 3 plus 1 is 4, so this will be 3/4 here, but Here we go. We have 3/4 x to the 4th power plus c. All right? So now, time for a challenge problem. Write this one down and see if you can work on it before I reveal how we finalize the answer. It is the integral of x plus 1 over the square root of x. All right, are you ready? Okay, work on it. Okay, let's see. Reveal how we do it. Put that there. Now, first thing you want to think about doing is rewriting it as two separate fractions. X over the square root of x plus 1 over the square root of x. Anytime there's a single denominator, we can usually put that with each of those numerators and separate them out. Then, simplify before integration. Rewrite this. This x over the square root of x changes to x to the 1/2 power. How does that happen? Well, recall that through the power of exponential rules, if I have x to the first divided by x to the 1/2 power, hopefully you can see that. Exponential rule says if I divide, then I subtract the exponential powers. So this becomes x to the first minus 1/2, and we get left with x to the 1/2 power. So that's how we end up with x to the 1/2 power. This one is just 1 over the square root of x, and that just becomes x to the negative 1/2 power. Now, we add 1 to each. So 1/2 plus 1 is 3/2. We get 3/2 in the denominator. Negative 1/2 plus 1 becomes positive 1/2 divided by 1/2. And so finally your answer is, once I take this denominator and flip and multiply by the reciprocal, I get 2/3 x to the 3/2 plus, this was 1/2, so it just becomes 2, right? Multiply by the reciprocal, 2x to the 1/2 power, and don't forget plus c. How many of you forgot to put plus c? I knew I'd catch some of you. Exactly. All right. Hey, listen, I hope you had fun with that. There is your final answer for the challenge problem, as well as a few extra examples for you to go through. All right. Thanks again. Hope you have a great day. Dykstra out. Thanks. See ya.